Okay, for example number 2, you really should put it on the same page, page 34. That's why there's 2 graphs on that page. So jot down y is greater than or equal to 1/2 x plus 5. We're just going to go through the example together. Take a minute and see if you can find out what the slope is, the m, and what the y-intercept is, the b. And keep in mind, you can rewind or fast forward at any time if I go too slow or too fast. So hopefully you found out that the m, the slope, is 1/2, which means we're going to rise 1 and we're going to run left or right 2. Whoops. And the y-intercept is 5, so that's where we are beginning. And you might have even went over to number 5. Hopefully you set up your graph. And you're plotting a point at 5. Now you're doing a rise of 1, so I'm going up 1 and over 2. And you want to make sure you're pointing positive. And it's just like graphing the line. Don't worry that it has greater than or equal to there. And remember, you want a nice long line, one that extends throughout the entire graph. Now, should we connect this with a dotted line or a solid line? When you see that it's greater than or equal to, that's a solid line. The only time you do a dotted line is when it doesn't have that equal to sign underneath it. So let's connect this with a solid line. And we'll extend it throughout our entire graph. Little arrowheads on the top and the bottom. Now remember what we did in the first example? After we graphed our line, we had to plot a point above and below and check them in the original problem. They don't have to be the same point like I used on the last one. You could check, let's see, 1, 7. That would be a point above the line. So in your original problem, 1 is going in for your x, and 7 is going in for your y. So it will be 7 is greater than or equal to 1/2 1. And notice I always, when I substitute in, I put parentheses around it, especially when there's a number next to it. 1/2 times 1 is just 1/2. And 1/2 added to 5 is just 5.5. Is 7 greater than 5.5? Yes. So sometimes next to my point, I even put yes. And you always shade over the point that works. So I'm probably going to be shading up. The only thing you do is you always want to check below, just in case you made a mistake. So any point that I can pick below, any point down here of my graph, I'm going to pick 0, 0. And it looks like I'm not going to be able to get to that right now. So I'm going to pick 0, 0. I choose 0, 0 whenever I can because it makes the math that much easier. Oops. Zero times 1/2 is 0. Added to 5 is 5. Is 0 greater than or equal to 5? Looking at the number line, no. So we want to graph and shade above. So above this line is the part that checks. That's where we had yes. So above, sometimes we draw just little lines. For those people who like it to be really organized, you can just draw a line straight up showing all these numbers work. So take this opportunity to shade in your graph, because that's really the most important part of this. That's what makes it different than graphing a line itself. So technically, we're almost done. All we have to do is go back and write the equation of the line on the line. And I always want to write the original equation. A few questions you might be asked are certain things in the solution? Is the 0.55 in the solution of the inequality? So you want to take a look. Where's that 0.55? Five is right here. Is it in the solution of the inequality? That means, is it being shaded over? Is it part of this graph? So the answer to that one is no. Let's try another one. Is the point -6.3 in the solution of the inequality? -6.3 would be right about here. So you want to see, is it being shaded over? Yes, it is. And the last one, is the point -2.4 in the solution of the inequality? I'll give you a second to try that one on your own.
This is a nice class in a row.
This point, -2.4, is right on the line. So what do you think? Is it part of the inequality or not? If the line is solid, it's saying that all these points along the line will all work. If the line is dotted, then it's saying this is the barrier. All the points above it work, but not actually on the line. So since this line is solid, we can say absolutely this point is in the inequality. So you can say yes. So now go back to the website and see where you should be headed.